Here are the views of two types of punch cards. Incidentally, Hollerith desk, otherwise known as Hollerith census machine, was the first machine to ever be featured on a magazine cover. This is the cover of the famous magazine named Scientific American. See the photos of Hollerith's desk on it. IBM continued to develop mechanical calculators for sale to business to help with financial accounting and inventory accounting. One unique feature of both financial accounting and inventory accounting is that although you need to subtract, you do not need negative numbers and you really don't have to multiply, since multiplication can be accomplished via repeated addition. But the US military desired a mechanical calculator more optimized for scientific computations. By World War II, the US had battleships that could lob shells weighing as much as a small car over distances up to 25 miles. Physicists could write the equations that described how atmospheric drag, wind, gravity, muzzle velocity, etc. would determine the trajectory of the shell. But solving such equations was extremely laborious. This was the work performed by the human computer. Their results would be published in ballistic firing tables, published in gunnery manuals. The US military looked throughout the country for female math majors to hire for the job of computing these tables. But not enough people could be found to keep up with the need for new tables. Sometimes artillery pieces had to be delivered to the battlefield without the necessary firing tables, and this meant they were close to useless because they could not be aimed properly. Faced with this situation, the US military was willing to invest in schemes to automate this type of computations. One early success was the Harvard Mark I computer, which was built as a partnership between Harvard and IBM in 1944. This was the first programmable digital computer made in US. But it was not a purely electronic computer. Instead, the Mark I was constructed out of switches, relays, rotating shafts and clutches. The machine weighed 5 tons, incorporated 500 miles of wire, was 8 feet tall and 51 feet long, and had a 50 feet rotating shaft running its length turned by a 5 horsepower electric motor. The Mark I ran non-stop for 15 years, sounding like a room full of ladies knitting. To appreciate the scale of this machine, note the 4 typewriters marked by blinking circles in the picture given on this slide. Here is a close-up of one of the Mark I's 4 paper tape readers. A paper tape was an improvement over a box of punched cards. You can observe the punched paper roll emerging from the bottom. One of the primary programmers for the Mark I was a woman, Grace Hopper. Hopper found the first computer bug, a death moth that had gotten into the Mark I and whose wings were blocking the reading of the holes in the paper tape. The word bug had been used to describe a defect since at least 1889, but Hopper is credited with coining the word debugging to describe the work to eliminate program faults. The first computer bug is encircled in this photograph. In 1953, Grace Hopper invented the first high-level language, Flowmatic. This language eventually became COBOL, which was the language most affected by the infamous Y2K problem. A high-level language was designed which was more understandable by people than the binary language which is understood by the computer. A high-level language is worthless without a program known as a compiler, which translates it into the binary language understood by computer. Hence, Grace Hopper also constructed the world's first compiler. Grace remained active as a rear admiral in the Navy Reserves until she was 79, and this was another record. The Mark I operated on numbers that were 23 digits wide. It could add or subtract two of these numbers in 3/10 of a second, multiply them in 4 seconds and divide them in 10 seconds. 45 years later, computers could perform an addition in a billionth of a second. Even though the Mark I had 3/4 of a million components, it could only store 72 numbers. Today, home computers can store 30 million numbers in the RAM and another 10 billion numbers in the hard disk. Today, a number can be pulled from the RAM after a delay of only a few billionths of a second, and from the hard disk after a delay of only a few thousandths of a second. This kind of speed is obviously impossible for a machine which must move a rotating shaft, and that is why electronic computers kill off their mechanical predecessors.